Okay, so the last thing to discuss during this lecture is how to design an econometric model. This is a very basic example. We're gonna do something much more complicated during this course, but nevertheless, I believe it should provide you with a general idea regarding the stages and the process. So we will do this based on the example with one variable model, which is called in this way because we will design model with one independent and one dependent variable. And as I told you before, econometric model, the design of econometric model is based on some piece of economic theory. So Keynesian model predicts that aggregate output, or GDP, denoted as Y, is described by the following function. K in brackets G, which stands for government spending, I, which stands for private investment, and C, which stands for consumption expenditure. In this model, K stands for Keynesian multiplier. So we are not going to go very deep, but we assume that Keynesian multiplier is always higher than 1. And this assumption results from the framework of this model. So we can test this hypothesis, like to verify whether the value of Keynesian multiplier is indeed higher than 1, using the following regression model, where YT stands for the value of GDP in the United States in quarter T. Beta 0 stands for the value of intercept. Beta 1 stands for coefficient of government spending, GT, in quarter T, in the United States, of course. So you could notice that we estimate this model based on time series data. By the way, in materials for this lecture, you can find all the Excel files which were used for estimation, so you can train and do it yourself. So as you can see, we design mathematical model, we establish statistical model, and here you can see how this data set looks like, as well as sources for data. So as you remember, in time series data set, we have date in the first column and then dependent variable and independent variables in subsequent columns. And in our case, of course, Y stands for dependent variable. So this is the variable to be explained by the volume of government spending. In this case, we omit investment and consumption, which is not the best strategy in econometric estimation. We will discuss this later, but for this basic example, it's more than enough. So model estimation process is not that exciting. Usually we use different kinds of software for this. During this course, we will use Gretel for a couple of very simple reasons. First of all, you can download and install it for free. I will leave the link for you in the document, so you could do this prior to the next lecture. Usually you choose the data set you'd like to use, you establish the model. Again, this time we use the simplest possible model, ordinary squares. Next time I'm gonna explain the idea behind this model. And this is the output. So this is a very typical output. So in this case, we observe 242 periods. That's why the number of observations is equal to 242. The coefficients stand for beta 0 and beta 1. So const or constant stands for the value of beta 0. This is the value of intercept or constant term in this equation. And this is the coefficient of variable G, which stands for government spending. So basically, you can put those values instead of values of beta 0 and beta 1 in this equation. And you will basically obtain a very simple linear function. So you can notice that coefficient of variable g is indeed higher than 1, which is in line with our hypothesis. But of course, more careful estimation regarding whether this coefficient is indeed bigger than 1 will require some additional analysis, as we're going to discuss during next lectures. P-value basically tells you whether the obtained result is statistically significant. I would like to indicate that probably you are not familiar with the notion of statistical significance at this moment, but please don't be afraid, we're gonna discuss this as well. So basically, if p-value tells you that variable is statistically significant, at least at 10% level of statistical significance, it means that the value of this coefficient is not equal to 0. So actually this variable causes some statistically significant effect on our dependent variable, or GDP. To summarize, government spending causes positive, because the value of coefficient is positive, and statistically significant, because p-value is less than 0.1, effect on the dependent variable. So you can use the volume of government spending in order to explain the value of GDP. Of course, this is not entirely in line with our research hypothesis, which stated that the value of this coefficient shall be bigger than 1. So it can only tell you that it's different from 0, but we're gonna discuss this later, as I told you before. So because this is a linear model, you can express the relationship between government spending and GDP using linear function or linear trend. So this blue line stands for the regression path, which was estimated in our model. So the value of intercept will be equal to the value of beta 0, and the slope is equal to the value of beta 1. So this is how you express the relationship between those two variables using linear model. So those red crosses stand for empirical observations. So of course, blue line is designed based on those observations, and this is just to compare how different our empirical trend, like what we see in real life, is from what we estimate. So actually it's pretty similar, even though you could notice that this segment is definitely much more linear than this one. But again, this is not something we're gonna discuss today. So we can only conclude that it's pretty decent. So the relationship between those variables can indeed be described using a linear model. And finally, we can use this estimation for prediction. So the coefficient of beta 1 is equal to 2.77, and it means that one additional dollar of government spending increases GDP by $2.77, and this result is statistically significant. So basically, using this knowledge, the government can estimate the volume of government spending which is needed in order to increase the value of output by some specific value. Again, this is a very simple and very basic example. In statistical offices, people use much more complicated models, but this was just to provide you with a general idea regarding econometric estimation. So thank you for your attention. That was it for this lecture. And next week we're gonna discuss more details related to linear model estimation. And I really hope you enjoyed this lesson. See you.